Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Today we have this Suoer. It's a power inverter with battery charger. Model number, as we can see, it is lda-1000c. It's rated for 1000 watt. The complaint was that this unit, or the customer, as he said and as he elaborated, it was charging and it was working fine. Suddenly he heard a loud pop and a lot of smoke came out of it, and it blew the circuit breaker. So I'm going to take it apart and see what is the problem with this unit. Now, in order to open this unit up, there is 4 screws, as we can see, and some of them is missing. That's not a good sign. And also on this side over here also there is 4 screws. So these, the 2 side covers, will open, and this down cover should slide right out. I'm going to do this off camera and I will be back. So here's the down sorry about that. So here's the down cover has been removed, and the curious thing that when I was unscrewing the screws, out of the screws, they the nut, or the case nut, or the case thread nut, they are no longer work because someone has been opened this and busted the screw threads. Not the screws are busted, but this is an aluminium, and aluminium is very sensitive in this case. As we can see, oh wow, this is the thermal sensor. It's disconnected, or it is out of the place. If we take a look in here, and just let me also, I have a poor lightning light in here. Just let me turn on the flash. So here we go. As we can see, the first problem, and the pieces, it's gone, and burn resistors in here. So the output diodes, they're busted. The transistor, the switch mode MOSFETs, they're gone. And if we take a look closer, and if we zoom in, there is a huge fire in here, and also there is a huge fire in this side also. And from these screws over here, someone was in here and tried to fix this unit, but obviously it failed, and that the customer failed to mention. And this capacitor, it's also banged. I'm doubting there is a problem. Yes, there is a problem, because this capacitor is dented. So I'm going to pull this whole assembly out and see what kind of damage in the circuit, and test it further before I decide to fix it or not. Curious thing, after taking a closer look at the circuit or the motherboard, someone put the capacitor on a holder, and if you know these type of Shure devices, the diode, the fuses, they came soldered directly at the base of the board, so the fuses directly soldered to the board. Not a bad idea, but come on, it wiggles. Yes, someone was in here, and pretty enough he did not do a very good job. Obviously did not do a very good job. The fan is working fine. If the circuit inside of this fan is working or not, I don't know. And and he necked the heat shrink. He exposed it. Someone unprofessional worked on this set, and this is the result. Let me take the rest of the screws out, and see what kind of a damage. Now, before I do that, if I take a closer look at the circuit, production date is 14/2/2011. What is this? Let me zoom in a little bit. Oh my god, someone bridged the voltage line in this way. What an idiot. Oh my god, he's an idiot. Very idiot. Let me see. What the hell is this? He tried to bridge this resistor and he busted the variable resistance. He busted the variable resistance. What an idiot! Missing in here. So when I was taking out the transistor holder out, I discovered that all of them, they are loose, they are barely crimped right. And as we can see around here, what an idiot. Oh my god, this unit had issues. Oh my god. So after I removed the transistor holders, and if we take a closer look, don't know if we can, this diode, a block of rectifier diode, it's obviously blown out and blown to smithereens. Someone was in here and he replaced this transistor and put the wrong size of insulation. It just pulls out. No thermal heat paste or whatsoever. And if we take a, oh my god, this is horrible. This is horrible. Basically, this is horrible, very horrible. This is bad. So after taking the PC board out, we can see this diode is completely blown, as we saw from the other side of the circuit. But and these solder is not factory. These solder traces are factory. We have a problem around here, and as we saw from the other side, there's an issue in soldering these two connectors over here. So what I'm going to do, test each side of the circuit aside, test the charger circuit and test the inverter circuit, and see what's wrong in each section. There's obviously traces of soldering in the area of the fuses, and look at the way he scar the heat shrink. But this is a lot more better than I expected. I mean, from the damage to the board, there is no visible damage to the board, as you previously see in a previous video when I also work on 2000 watt Suoer inverter. That guy was having a water damage and the solder mask came off, but in this case this board is very good. So I'm going to see what kind of damage in this circuit, pull all of these transistors out and test every single one of them, and I hope it will be an easy fix. So I took the transistors, the MOSFET, or the MOSFET in the other hand, out of the circuit for the PC board, and I test every one of them separately. The output FETs, both of them, there is 4 of them. Two are good and the rest is damaged. The the input shopper MOSFETs, 2 of the 10 is dead, and the other are damaged. 2 is damaged. That means 8 is okay. As for the charging circuit, as you can see, all of these components are dead, and this is one of the input chopper MOSFETs. As we can see, it's the pin got melted. As for the rectifier diode in the charging circuit, the 4 of them are damaged. So these 3 are one of these 3 are in the output of the charging circuit. They are the rectifier circuit for the charging circuit. As we can see, they are both dual. That means there is 2 diodes in the same construction, and all of these. And the curious thing, when I install the charging circuit, the MOSFET charging circuit, I found that these transistors are basically isolated, and because they are isolated, they doesn't need a cooling isolation like this. This is like a t-shirt for transistors like this. These type of cooling t-shirts, and they are basically they are horrible. I like Mecha more because they get dry. These type, they get dry. Even in Mecha designed or a Mecha assembly, they doesn't get dry whatsoever. These types of transistor, which they have the metal exposed or the heatsink exposed, they are designed to be installed this way. But this type, they doesn't even need a cooling pads or a cooling t-shirt like this, or an isolation t-shirt, whatever you want to call them. And so if you notice the other part, the previous part of the video, he used these isolation pads, isolation sheets, and he inserted the transistors inside those thermal jackets or thermal t-shirt, and then he crimped them. I don't know why he did this. He's obviously an idiot. These types, they are usually installed in the assembly and crimp basically to the metal with a thermal compound or a heat compound between the transistor and the metal case. But in this case, it's not, they did not use this. So what happened is, and that is my guess, that these things got so hot because there is no coolant to them to drain the heat of these components, and they got blown. He's obviously an idiot. I did not see someone like an idiot in this the same caliber like this person. So in the result, these components are bad, and if we count them, 1 2 3 4 5 6 7 8 9, 10 components are bad, and the rest they are okay, and these are okay. So I'm going to get the replacement in these, and I'm going to install them in a circuit, but first I'm going to power the circuit up and see if there is a chopper waveform out of the driver IC, which is typically SMD type TL494. It's a typical IC for driving these type of units, because it is very flexible IC, and it came also in a different sizes. There is the bigger size, and there is the normal size IC, and the SMD. Basically 90% of Suoer devices uses the SMD type. I prefer the regular type, the DP type, but they use the SMD because it's a lot more cheaper and they doesn't consume much room in the circuit. So I will be back. So I was cleaning the burn residue over this area over here, and let me zoom in a little bit in order to see it better. This resistor is toasted, and this resistor is toasted, and by the look of it, that he pulled this pad off. So, and this resistor is off. So what the hell did he do this to this circuit? I don't know. Oh my god. This is horrible. Some people are idiot, just idiot. And part of my language, but he is also, he's an idiot. Oh my god. So I'm going to try to paste this pad in its original place and install an SMD resistor here and see what happens. So I clean up the all the traces, and I tested the rectifier bridge, the 7 ampere 4 diode. They serve as a rectifier bridge, and they are working fine. And I also tested this fuse, and it is wrapped in a heat shrink, and it is working fine. But when I tested this fuse, which is this plastic type fuse, or they call it an electronic fuse, don't know why, but it is basically a fuse in a plastic case. If we just zoom in a little bit on this fuse, see if the camera will pick it up, is basically a 250 volt 5 ampere fuse. And the reason why this fuse exists in this circuit over here, it is existed to power those two chopper switched MOSFETs, which their position in the circuit and their status in the circuit is to drive this chopper transformer, or the output chopper transformer. So how this charging circuit work. It's basically the same design as you could find in the Suoer 40 ampere. The blue one. So, and the people who have these type of 40 ampere charger, they open it up, they will find the same type of parts, but in different assembly or in different models, but they are basically the same. So the positive goes from this capacitor to one lead of this transformer. The other lead will came from these two MOSFETs, which they are basically rated from 16 ampere and higher. So this fuse will cut the power, the positive power that feed these two transistors, these two MOSFETs. MOSFETs is basically a transistor, so there is no harm in saying these, but basically MOSFET, it's different than the regular transistor. So I'm going and these two transistors are driven through this transformer. This transformer is driven and controlled by this TL. Let me just zoom in a little bit. TL 494C, and this TL 494C is powered from this starter circuit. This starter circuit is always, as long as there is power into this circuit will always supply power. And this is a Viper 12A, and it will produce power by this lead and across these two a bleeder resistance, which is 1K, about a half a watt or maybe 1 watt. So I'm going to power this circuit up and see if this starter circuit it is working or not. And I tested this capacitor as I've previously elaborated in this video, because I found a little dent in it and I suspect that it is damaged. But according to the capacitor meter and the ESR meter, it is working fine. So this little dent probably get dropped, but it does not affect the component which is inside of the, or the elements which is inside of the capacitor. So I'm going to power this unit up, and I use these alligator clips that I made them myself. These are quite nice because they have this screw-in attachment, this alligator attachment, which is attached to the probe as a screw. So I'm going to power this unit up and hope does not blow into my face. And I set the voltage to 50 volt, scale. I'm going to grab the other lead, the positive one, and test if there is a voltage in this line over here. As we can see, there is roughly 14 volts, which is more than suitable for powering this IC over here. Now the next step is to test if this IC is giving the right frequency and replace these 4 resistors. I don't know about this resistor, it seems fine, but I'm going to test it anyway, and populate the diode, the output rectifier diode, in the other side, and close this chapter of the charging circuit. Close up the charger circuit. I'm going to test these driver transistors for driving the MOSFETs of the inverter unit. And I want to mention that this is a very well built inverter. I really like the construction of it. They made it very neatly engineered and very well lined up, all the parts, and they are using these 9mm, what this number is, let me just zoom in a little bit. They are using, in case of Q8, and we are out of focus, Q8, the 2SC 2655, the Q9, the A1020, Q7 A1020, and Q6, I believe it is the 2SC 2655. And that is quite amazing, because in order to drive this amount of MOSFETs, you need a higher power transistors or a lot of ampere, and the SS8050 and the 8550, they does not do the job, because they are rated for 1 ampere max. I don't know the specification of these transistors, but I believe from the size of them they are above the 2 amps and more, or maybe in 1.5 ampere. So I'm going to pull these out and test them and see if they are working or not. If they are working, so I believe there is a good chance that this lda-1000c is working fine. But I'm going to check the frequency, the output frequency of this IC, if it is correct or not. So I'm going to pull these out, confirm them, and then come back to the charger circuit. We are back on the Suoer. I install and I replace the TL494, because in the output of this IC, it has 2 output because it is a dual driver circuit. One pin it's giving a higher frequency than the other, so I replaced the chip, and I test these two PNP transistor SMD transistors, and they were fine. And I also replace the resistors that drive the MOSFETs and install all four of them brand new. And I also install a glass fuse, 250 volt 5 ampere, instead of the old plastic one, which is right here, this fellow, that it is blown internally. And I put some heat shrink isolation in it, so this should be very enough. I also installed the rectifier diodes, transistor type rectifier diodes. I installed all four of them, and they are, as you can see, they are metal type diodes, like that, not like the old one, which they were isolated. But in this case, all what I have to do, put some insulation, like they use to isolate the MOSFETs, and they are ready to work. So this entire unit has been all populated with all the brand new component, and I'm going to hook it up to the power outlet and insert and inject power in it and see if it will work or not. So nothing blow up. That's a very good sign. Let me hook the avometer leads. This is the negative and the positive. The not in negative, the positive, you can get it from the metal holder or the metal in the body of the output diode, because they are connected. And it is giving roughly 13.5 volts. Yes. So apparently this power supply is working. And I should mention that I disconnect the leads, the power leads, the charger power leads of the inverter circuit, because I'm testing this charger circuit separately. I don't want it to be tested in the and run power through it when I'm testing it, so it doesn't make any short or anything. So I'm going to hook some load to this circuit in order to see if it is running smoothly like it should, and if there is a drop in the output of the charging circuit. The best way to test any charger circuit is to put a load in it, and the best load for these is a 12 volt 5 ampere halogen lamp, which you can find them in in a car headlight or a motorcycle main headlight. So I'm going to connect one and bring my infrared thermometer and test this circuit and see if there is any heat dissipation or heat radiation is coming, excessive heat it's coming out of this circuit. So here we go. I power the unit up, and here is my thermometer, infrared thermometer. I'm going to check, as we can see, there's power. I'm going to check the heat in these two MOSFETs. 43, 34, 33.5, 33, it's around 33.5 degree. And let's test these. They are all okay. And test the output. They are also okay. Now I'm going to connect the load to the circuit and see if there is a emission of heat or what. And here we go. Here's the halogen lamp, and here is the load. It's not has been changed whatsoever. There is no change in the output of the unit. Let's test the as we can see, no change. So it is handling it very fine. No, here we go. About 2 degrees or maybe 3 degrees. And that is completely normal, because these things should run on a heatsink. It's not getting hot above a 40 degrees. This is cool. So the charging section in this unit has been fixed, and I'm going to turn and continue to fix in the inverter section. I'm going to install the MOSFET transistors and install the two 10 ohm resistors that they are blown, and replace them with the new ones. And I tested the TL 494, the shopper transistor driver chip, before I install the MOSFET, and test the frequency and the output voltage of it, because if there is any difference between the two output lines of the driver IC, it won't work and it will burn up the um, Suoer MOSFETs. So I'm going to install them and I will be back. So I install the two rectifier diode, and also I install all of these MOSFETs, and I replace this resistor over here. If we zoom in a little bit, the 10 ohm, and also I install this brand new, and as you can see, the old one, it's much smaller than the one I install. Not much smaller, but smaller than the one that I install. Also I tested the driver transistors, and they are all working fine. And I also test the IC, the TL494C, and it was giving the 39 kilohertz frequency on both of the output pins, and this is very fine. So this IC is working fine. The only thing I did not test is the output of the control ICs of the output transistors. And before I do this, I replace the trim VR, or the trim resistors. And the reason that this resistor is existed in this circuit, it is existed to control the frequency of the working frequency of the output MOSFETs, the output Suoer MOSFETs. As we saw, the resistor was overheated, and because he did as you can see, he melted the VR resistor by exposing it to heat. I don't know why, but he already did it. So this is a 100K resistor, a variable resistor, and it is giving up to 68 kilos. So this is the brand new 100K, and I set it about roughly about 50 Hertz, and I will confirm it by using my DMM and set it to Hertz measurement. So I'm going to power and hook a battery to this circuit, and there is a chance 5% or maybe less than that it will not work. So I'm using a very low capacitance battery. These two batteries will do the job very well. They are both 4.5 amperes connected in series, 6 volts. It will give me a 12 volt 4.5 ampere. So it will be perfect for powering this inverter section. As you can see, I disconnected, as I previously elaborated, I disconnected the charging leads from the charging port, and they will go in here because I don't want any interference from the charger circuit in testing the inverter circuit. So I'm going to flip this board on the other side and connect the battery and see either will get through these two a DC 260 volt or higher or not. So here is the back of the inverter unit. As you can see, I populated all the transistor and these two rectifier diode that rectify the power, the output power of the Suoer transformers. And I'm going to test the voltage in the output of the output capacitor. So I'm going to connect the negative. Hope it will not blow into my face. As we can see, let's see if we are getting any voltages. And we have voltage. Okay, I'm going to set the avometer to 1000 volt scale. Then I'm going to flip the switch, the on switch, and see what happens. The switch, it is damaged, and we are getting on a 1000 volt scale. So this means the battery is dead. So I'm going to install and hook some charger in order to boost the voltage of the battery, and so I can test it in a 12 volt normally. So I connected the my charger to the battery, and as you can hear it, it is charging the battery. And this is it's roughly about 12.5 volts, so it should power up very nicely. So as we can see, the charger is now powering the inverter, and the inverter, this is the fan, exhaust fan. It is working. Let's test the output voltage, and it is giving 200. As we can see, we are getting a 280 volts. So this is the 1000 volt scale. We selected the 1000 volt. This is a 1000 volt scale. This is 200, this is 300, this is 400, 220, 240, 260, 280. And we are getting close to 280 volts. which is very fine. So I'm going to turn it off and bring my DMM and test the frequency of the output chopper transistors before I install them in the circuit. And back to test the after disconnecting the charger, and after we have a very decent light, we don't need the flash anymore. I'm going to power up the unit and test the frequency of the, as we can see, it is giving 52 Hertz, and these kind of MOSFET, the output MOSFET, they don't run in a higher frequency than this. And test the other pin. They are spot on. So this inverter is ready to be to receive the output chopper MOSFET, and I'm going to install them and check the output of the unit. And here is the output MOSFET has been installed in the circuit, and I connected my DMM to the outlet and set the measurement to AC volts, and in order to see what kind of voltages we are getting. Okay, we are getting up to 232.9. It's roughly, it's the correct voltage. Now let's test the frequency. Okay, and it is, and we are getting 52 Hertz. So I'm going, after I reassemble it, readjust the trimmer in order to get it down to 50 Hertz. But apparently this inverter dash charger unit has been fixed, and it's ready to be assembled in the casing. So here is the inverter dash charger. Model number, as I recall, it was a lda-1000d2, has been all assembled, and I'm feeding it, and actually I'm charging it using the charger circuit to charge this 100 ampere battery. As we can see from the sound, the fan is rotating, and there is the indicator light. It is indicating charging position. So what I'm going to do, I'm going to flip the switch. I already connected a 300 watt to the outlet socket of the inverter. I put a 300 watt drill. I'm going to test it now. As we can see, when we flip the on switch, the switch to in on position, the fan will get louder because it is in the charging position. And this is the drill, the 3 ampere drill, but nonetheless this is a load. and awesome power. This is the only type of inverter, this type, the switch mode type that I really like. It's well constructed, and I really like the design and the outlet of it. So this unit has been now fixed, and I'm going to put the back cover or the down cover and secure the screws, the 4 screws that hold this plate in position. If you like this video, please subscribe and give me a thumbs up. Thank you for watching. See you next time.